So let's create the simulation that we have simulated from the shelf tool in the last video from scratch. So in order to create our simulation, we just need to create firstly the pool of the particles that we will just simulate in the DOP network or the dynamic operators. So first thing, I will add a geometry node. Let me rename this node as it was renamed within the shelf tool, so we'll just call it flat tank or flip tank initial. In this node, I'm just going to create not the ocean source, because the ocean source is more complicated, but I will create something simpler that creates a pool of water, which is called particle fluid tank. And this tank here has something called particle separation. If you just decrease this will make more particles, and you can scale it in the viewport like that, and change the water level. Okay, you can also change the jitter and the randomness of the water. So now we have our pool of particles. Let's create a null node. Rename this null node as out flip tank, and make sure that you rename all with the null node with the capital letters, so that you have the null node in the first order of your menu when you just try to select objects, and we will see this in the DOP network. So now we need to create our DOP network that where we will just simulate the particles, and we will call it O2 DOP network. Okay, inside this O2 DOP network we have this output node, which is not important at all if you just want to delete it. So we need to create our flip object where we will store the data. Okay, in this flip object, after this flip object we will just create the flip solver, which solves for the simulation, and here we have fluid to solve, which is our flip object. Okay, now as you can see here, there's just this cube which will not do anything, and this cube here is the default object that Houdini creates. So if you see, here's the initial data. We have this object, or this cube, as a default object. If we just delete this, it will disappear like this. So we need to import our flip tank here at the first frame in our simulation. So we will just change the input type to particle field, and in the particle field we will just select the flip tank, and you see here the null node is just in the first order because it's a capital, it's named in capital letters. Okay, so now we should have the particles here, but make sure that you change this to particle field, because if you don't change this into particle field, it will not recognize the points. Okay, and guides tab here, we see that we can just change the visualization at the viewport of our particles, the velocity, collision, and many things. For me now, what is important is just this particle tab here. We visualize particles as sprites, which is something like spheres. I'm going to change it to particles, and I will press D. In the geometry here in the viewport, I will display particles as disks. Sorry, not this. Lines, points, pixels. Yeah, I change it to sprites. Okay, sorry. leave it as points, but make sure that you display sprites here. Okay, so this is now our pool. We need to create the gravity. So to create a force of gravity, you just create the gravity force node and put it after the flip solver. So particles in our source, the simulation and DOP works upside down. So it first stores the data in the flip object, then solves for the simulation and applies the gravity force to the simulation. Okay, now if we just simulate our water, will just go down like that, because our boundaries here of the simulation is very large and doesn't match the boundaries of our flip tank. So if you just here see in the fluid solver and the volume motion, we have our boundaries here, or volume limits. We need to connect these boundaries to the flip tank initial boundaries, so that we have our boundaries closed and we have our simulation, and we don't want our simulation to fall, so we need to match these boundaries here. Okay, so to do this, we can just copy the parameter here and the size and go here to this Autodoc network, go here in the box size, paste relative reference, and the same for the center. Okay, which be, oops, I'm sorry, the DOP network, and paste relative reference. Okay, why you have a problem here? Error cooking swap. This unusual. Oops, no. Let me do that again. Here in the DOP network, in the SOP network, I will just copy parameter, then here paste relative reference. Okay, this is working now, and if we play now, our water will still move down, because here in the flip object we should unlock this closed boundaries. So now our boundaries is closed in all the directions, in the X and the Y and the Z. So if we press play now, our particles doesn't move down. Okay, now we need our sphere that will collide with this water, so we will just create a geometry node. In this geometry node we will create our sphere, and our sphere will be a polygon mesh like that. Create a null in order to import this sphere as an RBD object. RBD objects are affected by the gravity, but static objects, as we will talk about later, doesn't move with the gravity. So we'll just change the name to out RBD object. Okay, call this our sphere. Then in the DOP network, let me create an RBD object. In this RBD object we will just mention our sphere. Then to make this RBD object, which represents our sphere, to make it just collide with our simulation, we need to merge this with the simulation here. But you here in the DOT network, left inputs affects right inputs. So when you just add something that you need to collide with water, you need to make sure that this thing will be just connected to the left input of the merge node. So let me just here reverse the order, or you can just press Shift R in order to reverse the inputs. Okay, so now the sphere is connected to the left input, and left inputs affect right inputs, which makes our sphere collide with the things in the right input, which are fluid data. Okay, and if we just play now, our gravity will not affect the sphere, so you need to just to move the gravity, Control X, Control V, we need to move it after the merge so that it affects all the things upside. Okay, and here in this sphere I can move this sphere here. I should move it up like that. Okay, you can go here in this dot network, and I can use deforming object maybe. Why this is not folding, I don't know. We have our gravity, we have our sphere. So in order to make our sphere fold down here, we need to create an RBD solver, which I have forgotten to create, sorry. So create the RBD solver, which solves for the motion of the sphere with respect to the gravity and the fluid as well. So now we have our sphere that folds and reacts with our water. Okay, so this is for this video. We will talk about the import of the simulation into the SOP network in the next videos, when we just talk about the plane crash simulation. So this is for this video. Thank you for watching. Goodbye.